So let's have a look at the first type of confidence interval, which is a confidence interval for a population mean given it's a large sample. So to construct a large sample confidence interval for the population mean, we have two possibilities. So when the population standard deviation is known and when the population standard deviation is unknown. So in case sigma is known, we get the following interval. So x with the bar, which is nothing else but a sample mean, minus z alpha over 2, which will be the critical z-score for the given a over 2 level of significance, or alpha level of significance, which I will come back in a second. Sigma, this is population standard deviation divided by the square root out of sample size. So this is the lower boundary, and the upper boundary is constructed in the same way as just instead of a minus, we put a plus. When we don't know the population standard deviation, which is the most common case, we will approximate the population standard deviation with sample standard deviation. But the rest is the same. And now let's see what this significance level is. So there are three common significance levels in statistics, which is 10%, 5%, and 1%. And based on the level, based on the value of alpha, we can calculate 101 minus alpha. So we can get three values, obviously, 90%, 95%, and 99%, which will be the confidence levels. And as you've noticed, we don't simply use alpha, we use alpha over 2. So for 10% we get 5% or 0.05. For 5% we get 0.025 for 2.5%, and for 1% we get 0.005 or 0.5%. And each of these so-called significance level has its own critical value of the z-score. So for 10%, that will be 1.645. For 5%, this will be 1.96. And for 1%, it will be 2.575. The way those numbers have been defined is out of the scope of this course, this lecture. So if you're interested, I can provide you with extra materials, but for now you have to just believe me that this is the way it is. So I think this will be it for the z-scores, and now let's see how those confidence intervals should be interpreted. So we can be certain percentage confident. So in our case, we can be either 90%, 95, or 99% confident that population mean, mu, lies between the lower and the upper bounds of the confidence interval. So that the population mean lie between this value and this value with certain probability. Or another way the confidence interval can be interpreted is that the probability that the population mean, mu, lies between the values of the lower and the upper boundaries is 90% or 95% or 99%. There are two conditions that are required for a valid large sample confidence interval. So conditions that ensure that our confidence interval makes sense. First of all, a random sample that we will be working with, that you will be working with, that you will have to work with, it must be selected from the target population. And since this is a large sample situation, the sample size must be higher or equal to 30 observations.